Okay, Garnet Valley 8th graders, last class of lever. This one is Class 3. Class 3 levers have the effort force located in between the fulcrum and the resistance. So if you remember the free memory aid, your effort is now in between, so that's the E, so that's Class 3. This lever is usually used in sports equipment because it's going to increase the distance over which you're applying your force. This one is actually kind of backwards from the other levers. The other levers require you to do more distance with less force, and they give you more force with less distance. If you remember lifting the cat litter up with the first class lever. This one's the other way around. This one, you're going to have to apply more force over a shorter distance, and at the other end of the lever, you're going to get less force over a greater distance. And what that allows you to do is, if something has to move a greater distance in the same amount of time that your hand is moving, let's say, then the end of the lever is going to be going much faster. So in third class levers, speed is what we're trying to get. So the third class lever does that by increasing your distance. Let's go out to the garage and have a look. Welcome back. Last class of lever is the third class lever, and a great example of a third class lever is the hammer, and it is the hammer when it is being used to hammer in a nail. That's when it's a third class lever. The important thing to remember about third class levers is that the first two, usually, you are increasing your distance that you're applying the force over so that the lever gives you more force over a shorter distance at the other end. So the wheelbarrow allows you to lift up heavier things. You just don't lift them as far. Or when we were using this as a first class lever to pry something up, we were moving our hand a great distance and we were moving the object only a tiny distance. So it was multiplying our force. Third class levers are usually set up to be the other way around. They are there to multiply the distance. So they are actually going to decrease the force. Now, this doesn't sound right because you think, wow, Mr. Grandy, if I hit something with the hammer, it hits it with a lot of force. Isn't it multiplying my force? And the answer is no, it is not multiplying your force. It is decreasing it, because when you hammer something, your hand only moves a short distance, but the hammer moves a much greater distance. So when you're hitting something, when you're trying to strike something like a baseball or a tennis ball with a tennis racket or a nail with a hammer, F equals ma is not the right formula to use. You actually want to use the kinetic energy formula, which is Ke equals mass times the velocity squared. So you really are talking about picking up speed and having a lot of momentum, and the momentum of the head of the hammer drives the nail into the piece of wood. So when you have a third class lever, you have the fulcrum at the bottom, or in this case, it's kind of almost in your wrist or right at the very bottom of the hammer. And then your effort is after the fulcrum. And then the resistance is the head of the hammer. So if you look at it like that, you're going to get fulcrum, save that nail. You're going to get fulcrum, effort, resistance. So effort's in between, and that's the E. So if you did that FRE, that free thing for the class of lever, that makes this one a third class lever. So you can see how easily, if I try to just push the nail in with my hand, it's very hard to do. I can try and twist it. I can use both hands. It actually hurts a bit. But if I just put the nail in over here, let me get a little different thing, and just rely on the hammer multiplying my distance, and then it's real easy. Ooh, it's almost like an earthquake. So all of your sporting equipment, golf clubs, tennis rackets, baseball bats, lacrosse sticks, those things, field hockey sticks, they are all multiplying your distance so that you get more speed at the end of the lever, so that you're able to impart more kinetic energy into whatever it is you're trying to move. That's why when you're, if you play softball or baseball in Little League, as you get older, you have to move up and you go from hitting the bats that have the tremendous weight drop, like a -12, where the bat's 12 ounces lighter than it is long, and then the next year you got a year older, you hit like 6th grade or so, and you can only have a drop 3. So a 32-inch bat now weighs 29 ounces instead of weighing 20 ounces. And kids that hit, you know, deep line drives and home runs in the 200-foot field get to the bigger field and they can barely clear the infield. And like, what happened? The bat got heavier, it slowed down, you got less kinetic energy out of it. So all these third-class levers, they're all about increasing your distance. Fishing rod's another great example. I'll see if I can come up with another one to demonstrate for you guys to add on to this video. Well, I guess since I'm the golf coach, I got to get a golf club in here too. So this is my trusty 8-iron. This is one of my it's my safety club. Whenever I'm having a bad round or something's not working for me and I'm all over the course, which rarely happens anymore, by the way, just saying. This is the club I go to. I'll chip with this. I'll make a fairway shot, even if it won't get all the way there, just to hit it straight and hit it well. I'll use this club. And this is a third-class lever, because you can see, like, as I move my hands just a few inches, the end of the club is going a couple of feet. So it's really multiplying the distance. And the fulcrum is all the way up here at the top, and the effort is down here a little bit farther down in the handle. And by having your effort so close to the fulcrum, you're maximizing the distance multiplication. So this is really multiplying the distance. And if you want proof that this does not increase force, take a golf club or a hockey stick or even a baseball bat, and you could just set something on the ground. I'll just set this portable chair, and I'll try and move it with my hands. You can see how hard it is. It's requiring a lot of force on my part, where this thing barely weighs anything. It's not even that heavy. But because this multiplies your distance, it decreases your force. So it makes something, trying to move something like this, really tough to do. So that's why that's not what its function is. Its function is to increase distance, so you increase speed. And when you hit something with a lot of speed, you impart a lot of kinetic energy to it. And that's how you're able to hit golf balls, baseballs, softballs, all those things as far as you do.
Every time you do, it's gonna be 10 points. The first one to reach 150 points is my winner. And we have only one winner. Please use your mouth, not your hands, because the dinos do tend to bite. Are you guys all ready?